Hello everyone, today we are going to go over section 5.6, and in this video we're going to learn how to graph essentially the other four trig functions. We're going to start with secant and cosecant because they're most similar to techniques you already know, and then we'll get into graphing tangent and cotangent, which have to be done in a totally different manner. Okay, so first let's start with graphing a secant function. And it's going to go for both secant and cosecant. That really, if let's say here we're going to graph 2 times the secant of quantity 1/2 x plus pi over 4, we are actually going to pretend that we're graphing the cosine version of that. And I use cosine because we know that secant and cosine are reciprocals of each other, right? So if you see a secant, pretend you're graphing a cosine. And similarly, as we'll see below, if you're graphing a cosecant, pretend you're graphing sine for the same reason. Okay, so let's see here. The amplitude, okay, absolute value of 2, which is 2. The period of this graph would be 2 pi divided by the absolute value of the number in front of x. So divided by absolute value of 1/2. 1/2 is already positive, so the absolute value doesn't really do anything. But we're dividing by this fraction, so it's 2 pi divided by the fraction 1/2, which is 4 pi. Flip and multiply, right? The increment is you take that and then just divide it by 4. So just pi is our increment. And now the phase shift is negative the c value with its sign, so negative pi over 4 divided by this number in front of x here. So negative pi over 4 divided by 1/2, which is negative pi over 2. You would flip and multiply the 1/2. Okay. So now what you do is you start with your phase shift and follow your increment. So to get my next point, I add pi to minus pi over 2, and that is pi over 2. Now add pi to this, which would be 3 pi over 2. Then add pi to this, which would be 5 pi over 2. And then add pi to this, which would be 7 pi over 2. And now what we're going to do is plug in these values and see what we get. So here we would get 2 times the cosine of 1/2 times minus pi over 2 plus pi over 4. And this works out to be 2 times the cosine of 0, which is 2 times 1 equals 2. So at minus pi over 2, we get a value of 2. Okay, and now since we already know how to graph these, I'm going to kind of speed through the rest. For this one, you would plug in pi over 2 for x, and you would actually get 2 times 0, which is 0. And then here, plugging in 3 pi over 2 for x, you would get 2 times negative 1, which is negative 2, and then another 0, and then another 2. So the graph is going to go something like this. So here at pi over 2, we get a value of 0. Then at 3 pi over 2, a value of minus 2. And then at 5 pi over 2, a value of 0 again. And then at 7 pi over 2, we get a value of 2 again. And so this is going to look like a very typical cosine graph here. And again, no hard edges on those when the graph turns around. So it looks something like that, right? Okay, well, what I'm going to do is actually dot this, and I think I say so on your worksheet for this week. Graph like the original, i.e. Quote-unquote original function using a dotted line. So like if you're graphing secant, graph the corresponding cosine function using a dotted line, so something like that. And now what you're going to do to graph the secant, so watch very carefully here. Every time your cosine graph has a value of 0, the secant value is undefined because it would be 1 divided by 0, right? So you're going to get asymptotes here at pi over 2 and here at 5 pi over 2. Okay? And now if your cosine graph is above the x-axis, then you're going to start from that point, and because I'm going down to the right here, I'm going to go up towards my asymptote and to the right here. So I get something like that. And now here, I start at this bottommost point, and I go towards my asymptote in either direction. And here, I start at this topmost point and go towards my asymptote just in this one direction, right? And so the full line, the one that's not dotted, these graphs combined form the graph of one cycle, one period of the secant graph, okay? So you see, once you know how to do cosine, you automatically know how to do secant. And so we're going to do the same thing pretty much for sine and cosecant graphs. I encourage you to pause the video and actually graph this real quick, and you'll see that you should see the cosecant graph pretty quickly. Okay, so here we see the amplitude is 3, the period is going to be 4, flip and multiply the pi over 2. You'll see the pi's canceling. The increment is just 1, you just take this number and divide it into 4 by 4, and then the phase shift will be 1/2. So here I have the phase shift drawn. Let's make our little table here. 1/2, and now we increment by 1, so 3/2 is the next number, then 5/2, then 7/2, and then 9/2. And now plug in 1/2, you'll get -3 sine of pi over 2 times 1/2 minus pi over 4. Notice I get 0 in here, and I get sine of 0 is 0, so this will just be 0. The next one will be -3 times 1, which is -3. Then another 0, and then -3 times -1, which is 3, and then finally another 0. Okay, so let's see here. So here you see I've graphed the 3 zeros that I get from my sine graph, and now at 3/2 I get a value of -3, so let's come way down here, and then a value of 3 at 7/2, so up here let's say. And so this is just going to be a normal upside down sine graph as we've seen a million times before. And again, no hard edges, right? And once again, I'll dot this. Good enough, right? So we're going to do the same thing, and maybe you've already done this if you worked ahead, but everywhere that the sine graph has a 0, so in this case there are 3, right? Make an asymptote, a vertical asymptote that is. And now what do you suspect we're going to do over here? Well, we start at the bottommost point, and now this one will go down towards this asymptote as we go towards the left, and then this one towards this asymptote to the right, and then same deal up here, start with the topmost point and go towards the asymptote to the right, and this other asymptote to the left. And so the bolded, or I guess the non-dotted graph here is the graph of cosecant. And it repeats itself every, in this case, what is the period? 4 units, right? So the next picture over would be the same exact thing. You would have a piece down here, and then a piece up here, and same going this way, you would have a piece up here, and then a piece down here, right? But we're just drawing one cycle of the graph. Okay. In the next video, we'll pick up with graphing tangent and cotangent.